Okay. So the next concurrency pattern is join pattern. So as we all know, in order to efficiently make use of the entire system, we have to implement a multi-threaded system. That is, we have to create multiple threads that can execute the jobs in parallel. So as we have n number of jobs, they can be if they can be done in parallel, then they should be done in parallel, so that the in the end the response time to the customer is very low. So for that purpose the threads are employed. But suppose at some point of time there is a requirement that certain threads needs to be completed before moving on to the next step, then the join pattern comes into picture. For example, let's say your job is such that you have n number of jobs like this: job 1, job 2, and like that job 10. Okay. Now these 10 jobs can be done in parallel, and after these 10 jobs are completed, then only after all these have been completed, then there are two jobs that has to be completed, and they can be done in parallel. Okay, job 1 and job 2. But this requires all of them to be executed successfully before spawning this new action. Okay, so these are two job groups, you can say job groups: job group 1 and this is job group 2. And there is dependency that only after job group 1 has completed successfully, then only job group 2 can be spawned. So in such scenarios the join pattern comes into picture. Now what happens when these 10 jobs are encountered by the system? These 10 threads are spawned. Okay, so for job 1, thread 1 is spawned; for job 2, thread 2 is spawned; for job 10, thread number 10 is spawned. And all these threads, they start running in parallel, but they can finish the job at any point of time. There is We do not know for sure which thread is going to finish first and which is going to finish last. So what we have to do is we have to do the join operation on all the threads. So thread 1 dot join, this will wait till the thread 1 ends. Then thread 2 dot join, this will wait for thread 2 to end. Then thread 3 dot join, this will wait third thread to end. And likewise we can run this whole thing in a loop, so that when all the threads have been finished successfully, then we come out of this loop. So this loop basically makes sure that these threads have been successfully finished. Join will return only when the thread 1 has successfully completed the job. Join of thread 2 will return when thread 2 has successfully completed the job. And when this entire loop finished executing, then this means that this job group 1 has successfully completed, or all the threads have successfully ended. And only after that these new threads can be spawned. Now you will be wondering at what point this kind of scenario will happen. This kind of scenario will happen every now and then. You see here, suppose that you have raw data of every employee. Let's suppose you have 10,000 employees in your company, and each employee has the yearly data of attendance. Now, analysis on each employee can be done in parallel. So we can practically spawn 10,000 threads here to execute the job for each employee in parallel. But that will be kind of overkilling, because we saw in the thread pool pattern that if you have very large number of threads, then that does not mean that you have very highly efficient system. That only means that there will be lot of context switching, and because of context switching, it will going to become very inefficient system. So we have to have a very optimum number of threads so that we can take advantage of the multi-threading system. So let us say we spawn 10 threads, and this 10 thread means every 1,000 employees data will be handled by, on an average, one thread. Okay, so likewise all the 10,000 employees will be processed by these 10 threads, and after this thread has been finished successfully, there are two threads that need to run, which will generate the report on the monthly basis and on the yearly basis. So there is a monthly report and there is a yearly report, and both these reports can be run in parallel. So thread 1 and thread 2 can run in parallel, whereas the input to these monthly and yearly reporting system comes from these 10 threads. So only when these 10 threads have successfully finished, the output of these threads becomes input for these reporting threads. Okay, so how do we know that these threads have successfully completed? That is by these join operations, and this join operation makes sure that each and every thread has finished successfully, only to give the dependent result to the next job group. So that's how the join pattern comes handy to us.